filling out the Venn diagram. Okay, we ended with filling out the Venn diagram. All right, and you guys did a great job with this. Today we are going to interpret and do more with Venn diagrams as well as two-way tables. Okay, what goes along with a two-way or with a Venn diagram is something called, turn to the next page where you see SAT applications, okay, is this formula, okay? You could do this either using your Venn diagram or using the formula. Sometimes people are like, yeah, I don't even want to bother with a Venn diagram. It takes too long. I'd rather just use this, okay? So this is an option. This is called the addition rule, okay, in, formal terms. But if we wanted to find, for example, in this first question here, out of all the seniors in the senior class, 35% of students are on the honor roll. So that's one event, okay, on the honor roll. 35% of students are on the honor roll. 45% are athletes, okay? Then we have 22% of seniors are students who are on the honor roll and are athletes, okay? So we have a few things going on here. We want to find out how many seniors are on the honor roll or are athletes. Now, one thing here is sometimes your percentages might be over 100%. Like we actually saw, we would double count. That's what's happening here. So we want to subtract something called the overlap, which is the and, what they have in common. So you could use this formula. We actually did it the other day with the Venn diagram, okay? So the formula is probability students that are on the honor roll or are athletes equals the probability of honor roll plus athletes minus honor roll and athletes. Okay, this is the formal formula, I would say. We're going to use it a lot in terms of the Venn diagram, but it's always good to know. All right, so we know everything besides probability of honor roll or athletes. So we set up the equation. We don't know what this is, but we know honor roll is 35% plus athletes 45% minus the 22 that are both. By doing this, we actually find the whole percentage of the probability of selecting a senior who is on an honor roll or is an athlete. And what do we get? Liam? 58%. Good. 58%. Okay? So using the same thing, okay, the same formula as we just did, I want you to try number 2. All right, for number 2, what percent of seniors are in the school play or involved in a drama program outside of school? What did we end up getting? Danielle? 45%. So we have play, drama program, play plus drama. Whoa, hold on. Minus both. I don't know why I keep switching. Which is 45%. I don't know why it's not liking me right now. How many of you did get 45%? Awesome. Good. Okay, now I want you to read number 3. I want you to read number 3. What do we need to find now? Liam?
We need to find how many students that are randomly selected that are both a varsity athlete and are on.
Good. So we need to find and, right? So what do we know so far? What's given to us? Wes? The or, okay? So probability, athletes, or honor roll, which is 113, right? What else are we given? You know? Good. Athletes. 51 plus 74, but we do not know what is happening. We do not know the and, right? So when we do not know something in math, what do we have to do? What do we use? Yeah. Okay. Can we add those two together? And then subtract, right? We're solving for a variable, okay? We don't know what honor roll and athlete is. So we always replace it with a variable. So now we solve. 51 plus 74, we have to subtract that from 113 and divide by negative. How many seniors are varsity athletes and on the honor roll? Addison. 12. But then if I asked you, what is the probability of randomly selecting a senior who is a varsity athlete and on the honor roll, what would that look like? Rosanna? How'd you get it? Perfect. Okay, so look at the difference. In A, they're looking for how many seniors just in general. But when you stick on that word probability, we automatically created a fraction. Does that make sense? Okay, let's turn to the next page. Lesson 2 in terms of Venn diagrams. Put this in place. Okay, any of my lacrosse players out there? Some of you are, so is that Sticks or is it STX? Can someone enlighten me? No? It's Sticks, right? That's what I thought. But I don't know. I was second guessing myself. But anyway, thank you, Wes, for talking up. All right, so we're going to fill out this Venn diagram, okay? A company is performing a market test on 2 different lacrosse stick brands, Sticks and Maverick, for its new product line. Out of 150 people, so this Venn diagram has to equal what? 150. So we know the total has to equal 150, okay? 60 like Sticks, 95 like Maverick, 25 like both. So where should we start when we fill this out? Danielle? Both, which is 25. So remember, both goes in the middle. We have to label our circles, and we'll label S and M. Okay? So we know 60 like Sticks. So how would I show it? What do I have to do? Yeah. Why 35? Perfect. So we have to take the total minus the both to get 35. Because this whole circle has to equal 60. So 35 people only like sticks. How about Maverick? Yep. 70. Good. Okay. And then what else? What does that add to? 130. But what do we need? 150. So there's 20 unaccounted for. What do we do? Louise? Good. Put them in the box. 150 minus 130. Okay. So we have some questions. What is the probability that a person likes sticks or Maverick? Assad? What is it? How'd you get it? Sticks or Maverick. Okay. Yeah, Tina.
Oh, it's 35 plus 70, so it's 105 over 50, which is 7.
Plus what else? Yeah,
Plus the 25.
plus the 25. So it's either or. Okay. So who likes sticks or Maverick? It's 35 plus 25 plus 70 all over 150. Okay, so anytime it says or, it's only sticks, only Maverick, and both. Okay, because it's including. Okay, you don't want to double count the 25. So we have 130 over 150, 13 out of 15. Okay. What is the probability that a person does not like either? Lila. That doesn't like either. Did you say 25 or 20? Okay. Louise? It's 20 for 150. 2 over 15. Does not like either is on the outside. Okay. What is the probability that a person does not like sticks? Genevieve. How'd you get it?
I did 90 over 90.
No, you're right. 90 over 150, which reduces to yeah, Rosanna. 3 over 5. Okay? Now, where it says does not like sticks, you have to add the 70, which is just only Maverick, and the outside. So 70 plus 20 gives you the 90. Okay? What is the probability that a person does not like the Maverick stick? So what would that be? Yeah. What was it before? Okay, so let's recap because I'm not really sure where everybody is. Okay, for a Venn diagram, where it says or, okay, where it says or, you're adding up, in this case, 35, so only sticks, who likes both, and who likes only Maverick for or, okay? It's either sticks or Maverick or both. When it does not like either is the outside, okay? What is the probability that a person does not like sticks? You have to add up only Maverick and the outside, because the outside also includes does not like the stick, okay? Same thing for Maverick. Does that make sense? Can't really tell. You guys are very, very quiet. What's happening? So the probability that a Ludlow student has been to Florida is 44%. The probability that a student has been to Vermont is 60. The probability that a student has been to either Florida or Vermont is 83. Use the Venn diagram. So what are we missing? What don't we know? Brayden?
We don't know how many have gone either. Well, I guess we do.
Okay. Yep.
We know the percentage of students that have been there, but we don't know the actual total amount of students.
Well, we just need the percentages. So our Venn diagram is going to equal 100%. Jack?
We don't know what percentage of students that have been to both.
Perfect. We don't know this both key. We don't know that. We know or and we know each. Okay, so how do we find it? Do we use the formula from before? You can. Find who likes both, who's been to both. Go ahead. All right, so we know probability of Florida is 44, Vermont is 60. To both, altogether, Florida or Vermont is 83. How many have been to, what percent have been to both Florida and Vermont? 21%. How many of you did get that? Good. So 21% is in the middle. And you get that by 83 equals 44 plus 60. And you have to find that middle. Okay? You get 21. So what percent has only been to Florida? Madison. 23. What percent has only been to Vermont? Danielle. 39%. Then what percent of students have been to neither? Brayden. 17%. Okay. 17 have been to neither. And what percent of students have only been to Florida? Danielle? 23%. Okay. How many of you did get this whole thing correct? Okay. Where are the problems? Where are the problems? Because looking around, the majority of you were doing this. Others were stuck and not sure where to start. Okay? Yeah, Liam?
I think a lot of it has to maybe with the risk of going potentially above that 100% cap.
Mm-hmm.
At least around it.
Right? Good. So if you were to add these together and know that you're over 100%, then something has to be taken out somewhere. Okay? Even if you added those together, what is 104 minus 83? 21, and you get the middle part. Okay? Which, if you just did from the beginning, you could have. There's a ton of ways to figure this out. Okay? The formula is just the surefire way right now as you're just seeing these like for the first time. Okay? So we will do a lot of practice with these and understanding how to create these Venn diagrams and also see them a different way in a few minutes in terms of two-way tables. Okay? Two-way tables are actually a lot easier to understand, and they are all over the SATs. Two-way tables are all over the SATs. Okay? So one thing, when we get to two-way tables, you want to make sure, even on your practice and whatever you do, you always want to total out your two-way tables. Each column, each row, you want to have a total for. Okay, because you will need that when you're finding probability. Okay? Some of the shortcuts to remember in terms of two-way tables, which are important. A lot of people didn't read this in my last class, and we got stuck. Okay? if you see the word or, okay, you are still adding the cells that include one event or the other. You're still adding together, and I'll show you what that means shortly. If you're looking for and, if it says and, like for example, what is the probability, or let's say how many people are male and like football, it would be 40. You notice there's no multiplication happening. Does that make sense? Okay, so on a two-way table, when you're looking for and, you're finding where they're both in common, where there's an intersection. Does that make sense? Okay? Given is the dependent. So if it says, determine the given event and make this your new denominator. If it starts off with given, they like football, this total would be your denominator. Out of that total, how many are male? So 40 out of 52. So it changes that way, okay? A lot of things with probability is all about comprehending what it's asking. And it changes multiple different ways, okay? So what I want you to do first is fill out this total column, okay? Fill out that total column first. Okay. How many males were there? Cece. 77. Emma, how many females? 70 what? 73. Thank you. Jackson, how many in total? 150. So 150 people were surveyed. Okay? 150 were surveyed. So now, we're going to keep these in fraction form, reduced if we can. All right? What is the probability that a person surveyed favored watching football on TV? So start with our initial fraction, then we'll reduce after. What would it be? Wes? Good. 52 over 150. What would that reduce to? Do you know? 5. Good. Okay. What is the probability that a person surveyed favored watching basketball or baseball? Grace. Excellent. 98 over 150 ends up being 49 out of 75. Okay, so for this one where it says or, we added together basketball and baseball totals. Okay, so what is the probability that a person surveyed was male? Liam.
77 over 150.
Good. Excellent. Okay, so here, important. Okay, what is the probability that a person surveyed is male and favors basketball? Okay. Go ahead, Wes. 22 over 150. We got 11 out of 75. Okay, everyone so far so good? Okay, the and is male in basketball. Okay, just that. You don't have to do anything else. Now we get into given, okay? Where you see given the person is female, the total number of female is your denominator, okay? How many females were there? 73. So out of those 73, how many of them favored football? Brayden? 12. Good. Okay? And if we look at G, given the person favors football, what is the probability they are female? Go ahead, Noah. Good. We have 52 for total number of football. 12 female, 3 over 13. Good. What is the probability a person surveyed is a female and favors baseball? Louise. 45 over 150. Good. Okay. Now we have to figure out what probability is greater. Okay. Remember the reading. Whatever for this notation, whatever comes second, so baseball, that's going to be your denominator. Okay, so how many people favored baseball? Anybody just call out? 60. Out of those 60, how many of them were male? Okay, which reduces to 1/4. Okay. Then the next one, female football. So how many people like football? We already did this one actually. 52. Okay. Which one is greater? Sad? 1/4. Good job. All right. So you're going to try one on your own. Okay. You're going to try one on your own. Number 2. Okay, you're going to try number 2. Moment of truth. So, 2A. How many 2-year-olds were surveyed? 20. That must have been really... I'm thinking of my own 2-year-old and trying to be surveyed. Anyway, sorry. Just dawned on me. So, 2B, it's just asking how many people are right-hand dominant. So, how many people? 16. It's okay. 16. Then, 2C, what is the probability that a person is left-hand dominant? Someone who is not up here. Rosanna. 3/5. Good. Okay. What is the probability that a student surveyed is 18, 1/2. So far, what you see in this first column, 2A through D, are correct. Okay. We'll get to 2E in 1 second. 2F. What is the probability that a person is an 18-year-old and is lefty? Danielle? 3/8. Good. In 2G, what is the probability that given the person is an 18-year-old, they are lefty? 3/4 is correct. Okay. Yeah, Liam.
Never mind.
Okay. Okay. Now E, we have a few different answers here. The correct answer, and you guys will explain, is 5/8. Okay. Nolan or Danielle, both of you were just explaining, so go ahead.
Okay, do you want me to explain it?
Yeah, sure. Go ahead.
So they can't overlap, so you can't add up their, actually look at it again. It's 2-year-olds or righty, so you can't add the righty number to the 2-year-old's number because then it's overlapping the 2-year-olds who are righty, so you have to make sure that you're just doing the 18-year-olds who are righty for the total number of 2-year-olds.
Okay. And I will show you the difference with, I'll show you the difference. Here, you have 2 different scenarios. You have ages here and left or right, right? Okay? So when you look at 2-year-olds, 20 out of 40, right? Plus righties, right? 16 out of 40, you have to subtract this overlap because it's counted twice. Okay? So here you have two separate measurements, so to speak. You have left and right is one event. 2 years and you have ages here. As opposed to the basketball and baseball, they were all under one scenario. So that's why we could add. Here, there's an overlap. Does that make sense? Okay?
So where do we subtract it from?
So when you go through, so 2 years old, so you have two events, right? Probability of being 2 years old is 20 out of 40. Plus, probability of righty is 16 out of 40. Then you minus where they're both occurring, 2-year-old and righty. So you take that total, 20 plus 16 is 36, minus the 11. Okay? Yeah, Dina.
If you just had the 20 and the 5.
Yeah, you could do that too. Yeah, you could do that as well, of where it doesn't, what's left over, basically, I guess. I'm going to look at it that way. Okay? Any questions regarding those? Okay? So one thing with the probability and understanding two-way tables, that's pretty much the only confusion in some cases, but you have to look what's given to you. Okay, so to finish out today, I want you guys to try, because the homework practice got all screwed up, but I want you to try number 3. Okay, I'm going to give you about 5 minutes or so, not even, like 4 minutes, to complete these 3 using the two-way table, okay? We'll go over quickly the answers, and then I want you to have your homework packet somewhere on the side because we have to circle the numbers because they're all screwed up, okay?